Okay, I put grades in for 4.1 and 4.2, big ideas. That was due last night. I've been pretty lenient up until this point, just letting it turn things late. But so if you've got a 0 on that from yesterday, you turn it in today, you'll have a 90%. Turn it in tomorrow, 80%. I'll try and get better at following my own guidelines. Okay, so most of you hadn't done 4.2 when I put grades in, so make sure you get that done because we're on 4.3 is due tonight, and today is talking about 4.4, and that'll be due tomorrow night. We will have a quiz on 4.1 through 4.4 tomorrow, so it would probably be to your best interest to actually do the 4.4 assignment, try and get caught up on your big ideas work so that you are successful on the quiz tomorrow. Okay. Yesterday we talked about 2 ways that we can show triangles are congruent: side, 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 angle, side. This section, we learned 3 new ways. I really consider it 2 ways: angle, side, angle. Okay, where the 2 angles and the side have to be consecutive, just like the side, angle, side was. It can't be any 2 angles and a side. It's got to be angle, side, angle in that order, or angle, angle, side. Okay. The 4th way is called the hypotenuse leg. Sometimes you'll see it referred to as HL. But if I look at the hypotenuse leg theorem, it only works for right triangles. And it says if the hypotenuse of one is equal to the hypotenuse of another, and a leg of one is equal to the leg of another, you can prove that this is, or you can use that information to prove that it is they're congruent triangles. I think of this, why do I think of this as hypotenuse leg? You could probably prove this one through side, angle, side, because the angles are already equal, right? You could use side, angle, side, or side, 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 or something like that to prove this one. Anytime, my advice to you is anytime you see a right triangle and another right triangle next to each other, and they give you 2 things, and they want you to tell them what the theorem is to prove they're congruent. If it's a right triangle, it's probably going to be the HL, the hypotenuse leg theorem. Okay, if it's not a right triangle, it's going to be one of the other 4. Side, 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 angle, side, side, angle, 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 side. Okay, so the 2 new ones that we learned in addition to hypotenuse leg are angle, side, angle, and they have to be continuous, okay, or angle, angle, side, and these don't. I could have these 2 angles in this side and these 2 angles in this side or that side, but the corresponding parts have to be congruent. I can't have angle, angle, side here and angle, angle, side there. Does everybody see the difference? You just have to kind of follow the corresponding parts and make sure they're in the same order. Okay, so we have side, 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 angle, side we learned yesterday. Angle, side, angle, 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 side we learned today, plus the hypotenuse leg theorem, which is when 2 triangles that are 90 have at least a side and a hypotenuse that are equal. The 2 triangles are congruent. Okay, and why do we care in geometry? Well, most of the time in geometry you're trying to prove something about a corresponding part in a triangle, and you can't do that until you've proven the triangles are congruent. So if you can use information you're given to prove the 2 triangles are congruent, then you can show a relationship between another corresponding part in the triangle that you weren't given as far as information at the beginning. Does that make sense? Okay, so like on the ACT, what you might end up having to do is they give you 2 triangles, and then you have to pick what the congruent statement might be from those 2 triangles based on your knowledge of these 4 theorems, plus the hypotenuse leg. Okay, it's difficult. You're not going to have a proof you have to do on the ACT. But you may need to know whether or not you could say those 2 triangles are congruent based on one of these 4 theorems. Does that make sense? Or, if they give you 2 triangles that are congruent, and being able to see what their corresponding parts are to be able to solve like we've been doing, for sides and angles. Okay. Same deal on big ideas this week or tonight. It's going to be having to pull in answers. You know what I mean? On proofs. You're not going to have to write your own proofs, but you'll have to pull in statements or reasons. Okay. Let's look at the textbook check. The postulate you would use to prove these two triangles below are congruent is what? Angle, side, angle. Okay, because we've got two angles and a side between, and they're all consecutive. What information do you need to prove these two triangles below are congruent using the angle, angle, side postulate? Angle, angle, side. So angle, side, angle would be F and Q, right? But we aren't using angle, side, angle. We're using angle, angle, side. What's that? G and P, is that what you said? Yeah. Question 3, if the triangles below are congruent using angle, side, angle, what angles must be congruent? F and Q. Everybody see that? Question 4, triangles below are congruent, true or false, using the angle, angle, side postulate. It's false. This one was hard. But if you notice, the side that's congruent here to this triangle is not the side. This side is the one closest to the angle with the 1 mark, where this side is closest to one with the angle with the 2 marks. So they aren't corresponding parts in the triangle. So angle, angle, side won't work here. Or, yeah, it has to be a different side. And the last question, after proving these triangles below are congruent using the hypotenuse-leg theorem, you would justify side AC and side XZ are congruent using what? Yeah, CP-CTC. Remember, CP-CTC is what you're going to use after you've proved the triangles are congruent to show that corresponding parts of congruent triangles are congruent. That's what CP-CTC stands for. Corresponding parts of congruent triangles are congruent. You can only use that after you've proven the two triangles are congruent. So if they want to say, are these two angles congruent, you say yes by CP-CTC, corresponding parts. Okay, so go ahead and try and get caught up today in class on your big ideas. We do have a quiz tomorrow, so make sure that you're at least looking at problems from 4.4 as well tonight, so that you're not blindsided by something tomorrow. All right. Quiz 4.1 through 4.4.